Hi, this is Ben McCone with Technically Speaking at Source Allies. Today we're going to be talking about DSPy, specifically the claim to fame of DSPy, prompt optimization. We can see since our last video, DSPy 3.0 is officially released, and on their homepage they have some examples of prompt optimization, specifically for RAG, for React agents, but today we have a prompt that we will be optimizing for a use case that we will go through here in a couple of minutes. First, let's go ahead and instrument our notebook so that all of our traces, all of our interactions with DSPy are logged within Arise Phoenix. We will look at that here in a couple of minutes. Today we are using Open Router so that we can use an older model, but one that is less powerful and very, very cheap. So in here we will see Open Router's API key is in my environment variables, and then we can check to make sure that when we call this model, we can successfully get a response. It looks like Llama wants to play a game with us. So let's go ahead and import some test data. For this use case, I pulled a data set off of Kaggle, and this data set, what it gives us is a list of support tickets, the questions being asked, what was that ticket's category, what was the customer's intent, and all of this allows us a very good training set. A good use case would be something like an internal support ticket system if you have one for customers. One of the hardest challenges with those systems is picking the correct category and therefore the team that it should be routed to in the beginning. So with this, today we are going to be taking these customer utterances and we are going to be working through a prompt to get the proper ticket category sent to us. Now, as we can see in this next step, we have about 10 different categories, maybe a few more, maybe a few less. This is very important. We also have many intents, so more to come on that, but we will be grabbing a sample size of category intent combinations so that we can make sure that we have a good collection of testing and training data for DSPy to use. Scrolling right along, I have brought those ticket categories into a Python type. We have built a very simple DSPy signature. It simply takes in the customer utterance, returns the ticket category, and gives us a predictor. Again, as we had talked about previously, that we'll leave in, but that is later. We will show that. But this predictor, as we had talked about in previous videos, you should check those out if you haven't already. Links down below. This is a zero shot. It does not necessarily provide out of the box any examples to the AI. So that is set up. We can call the predictor, but before we call it, we need data. So for each of those intent category groups, we are grabbing 10 from each for training, 5 of each for testing, and we have a little function here that actually pulls that out and makes sure that we don't have duplicates across the two categories. Finally, we put those dictionaries into DSPy examples, tell it what are the inputs, and that gives us our training and testing examples. Really quick, let's look at how many that is. Len of train examples and len of test examples. We have 270 and 135 respectively. Now let's talk about optimization. Optimization is key within AI, but just like evaluation that we've talked about before, we have to define what is our function that we are testing against. In this case, it is very simple. A DSPy evaluation function simply takes in the example, what we created up above, the prediction, what the LLM actually produced, and it compares them. So in this case, we want to simply say that the ticket category that is produced is exactly the same between the example and the prediction. So let's go ahead and run this and see what comes out. What is the issue? Evaluate call looks like with DSPy 3.0, this is no longer supported. So let's go ahead and run without that option. So this will run fairly quickly. We can see that Llama really struggles with this problem. Early on, Llama was around 50%. It is increasing. It's actually performing quite well today. Being a language model, it is non-deterministic, but we came in at about 85%, 86% if you round accuracy across that data set. That's not great, but that does mean that 15% of all tickets are going to go to the wrong team initially if we used this out of the box. Let's see if DSPy can improve that for us. So DSPy has a number of optimizers. One actually was just released with that 3.0 release called JEPA. I don't know if I'm saying that right. It is either JEPA or GEPA. Let's go ahead and see. I don't believe that they have a pronunciation, but that is a very cool prompt optimizer. We may look at that in a future video. Today we will be looking at Simba. Now Simba operates in a few different ways. Let's go ahead and run this, and while that's running we can walk through what Simba is actually doing along the way. So Simba pulls together what are called mini batches, and it runs multiple steps along the way. So what that means is it is pulling examples from our testing set that we created earlier, those 270 examples, and then it starts creating candidate programs, and it does one of two things each step of the way. It either adds a rule, in which case that means it is a description that goes into the prompt, or it adds an example, actually pulling one of our examples either from our set or generating one with a large language model. So it does that 4 batches. I believe it creates 6 or 7 programs by default in each batch, and then it tests them against each other to understand where is the highest scoring batch that we see today. So this will take a couple of minutes. We will be right back once this completes, and we'll take a look at what's going on here and in Phoenix. All right, welcome back. Simba has now completed after just under 6 minutes, and we can see that over the many different candidate programs that it created, the best one that it found over our training set scored a 98%, which is very good. Now the key here is that we can't trust that number itself, because earlier in this demo, we had created a separate train and test set, and this evaluation has only been done against that training set. So let's go ahead and run evaluate, that same evaluation that we ran earlier, against the compiled program that has been optimized by Simba. So here we can see immediately this is behaving much better. Early on, where we were at about 50%, leading up to about 86%, we now came in at a whopping 97% over our test set, and this is a much better improvement. Rather than about 15% of tickets being incorrectly categorized, we're now down to just 3. That's 3 out of 100 that requires very little human intervention, saving us that much more time. Now the key is, with DSPy, that would take a long time if we needed to run that evaluation at every single deployment. That is where these evaluations, or rather these compiled programs within DSPy, are very exciting. Let's actually, before, here we will really quickly save our Simba model.json, and we don't need to save off that original program. So let's save that off. That opens up Simba model for us, and we can see this is what is actually being saved under the hood. We see that there are 2 demos. These are examples that DSPy shows to the AI along when it is asking questions. These must be types of problems that were causing issues previously. And then these are the instructions that have been generated. Given these fields, produce a ticket category. When producing the input, pay closer attention to the intent behind the customer's question. If the customer is asking about changing their profile, it is likely a count. The important part here is not the instructions, but is that we did not have to write this or figure out what the perfect prompt was. Let's switch over to Phoenix. We talked about this earlier, and this gives us the ability to see what is our AI program doing? What is our program doing in general, but more importantly, what is that input and output, and where might the AI be going wrong? So let's go ahead and look here just at the latest example. This is one of those evaluations, and we can see, help me set up a different shipping address, and the ticket category is, I would agree, shipping address. But under the hood, here is again that prompt. Here's the input fields, here's the customer utterance, completed in adhering, given these fields, produce that, and here is that same prompt that Llama created for itself. Another really cool feature that I like about DSPy is it not only tells us what our program is doing, but it also tells us how efficiently it is behaving by telling us the number of tokens. And because I configured earlier the Meta Llama 3.18 billion model in the list of models, it now knows how much each of these runs costs on an ongoing basis. So we can see that for this entire demo, this has only taken about 2 cents worth of funding for this large language model usage, allowing us to correctly categorize our tickets from customers or internally, and have those routed to the correct teams without seas of complex forms. Now, I teased earlier that we were able to save this model. This is very important because we can see that if we restart, let's scroll back up to the top, and it's as if none of this code was ever run. Let's register again, let's create our model, and let's go ahead and import our data. Come down here, we will create our signature and our predictor one more time. And finally, let's go ahead and run our evaluation. And we will see again, we're back down performing poorly. We're seeing 60, 70%. Now, because we did rerun this, that data set is different. So again, we will be seeing a different number. Looks like we came in a little bit higher this time at about 87.5% rather than 85.9. But rather than running DSPy.Simba, let's run predictor.load Simba model.json, and then let's just run evaluate again. And what this does under the hood is this brings those same examples, that same prompt back into the program so that we can deploy, this JSON can be in our repo, we can commit that to source control, we can load that at runtime, and then we see that immediately without having to run that 6-minute process of compiling Simba one more time, we instead have that immediately just by loading that JSON file. This has been Ben McCone with Technically Speaking at Source Allies. Do you have a topic you want to see covered? Comment down below. Check out sourceallies.com to learn more about us. Thank you, and we'll see you next time.